Now let's discuss the definition of linear inequalities. So here are the four symbols that inequalities are expressed by. So let's take this first one. This first symbol means greater than. So whatever number is on the left hand side of this uh, symbol is basically greater than whatever number is on the right hand side. It may not be really a number, it may be any expression, really any variables. So for example, let's say 4 is greater than 3. This is true. And we can also say that, say 2x is greater than 3y. So 2x is greater than 3y. Since 2x is on the left hand side of this symbol. You can also basically see that there is a way to remember this. Basically, whatever direction the mouth of this symbol is pointing towards, that's the greater number. So for example, in this second one, you have this less than symbol. So whatever is on the left hand side is less than whatever is on the right hand side. And so basically, again, let's just say 3 is less than 4. And again, you can remember this by the fact that the mouth is pointing towards 4. So 4 is greater than 3. So basically that's the same thing. This expression and this expression both are the same thing. And similarly, if you use this particular expression over here, you can write it down like this: 3y is less than 2x. So 2x is greater than 3y, 3y is less than 2x, both are the same thing. Now, if you apply this little addition, this line underneath the symbols, that would mean equal to. So for example, let's just say 2y is greater than or equal to 4x. Let's just take this as an example. That means that in the earlier case, which was this one over here, 2x is greater than 3y. It does not say that 2x may be equal to 3y. It just says that 2x is always greater than 3y. So over here, we are saying that 2y is greater than, but it is also equal to 4x. And similarly over here, let's just say 4x is less than or equal to 2y. This expression and this expression are the same thing. Again, the direction in which the symbol is the symbol's mouth is pointing towards is the greater number. Now, look at these examples. We discussed some earlier, but let's just say this one over here. As you can see, ax is greater than b. Ax is less than b. Ax plus by is greater than or equal to c. Ax plus by is less than or equal to c. So we've used this. Now, here's the important part. The inequalities 1 and 2, so this one and this one, are in one variable. As you can see, the only variable in this is x. A and b are constant numbers. Are basically this a and this b, this a and this b as well. They're constant. The only variable in these two equations is x. So it's a one variable inequality. While the inequalities 3 and 4 are in two variables. As you can see, we have x and we have y. Two variables, x and y. A, b and c in both these inequalities are just constant. So that's that. Now, the following operations will not affect the order or sense of an inequality. So basically what we mean by this is that 1, adding or subtracting a constant to each side. So basically you can let's just say we have x is greater than y. If you just add 4 to both the left hand side and right hand side, it will not change anything. X plus 4 is greater than y plus 4. We can prove this by basically writing down, let's say we have 4 is greater than 3. Very true. So 4 plus 4 is greater than 3 plus 4. Also true. And you can also subtract 4 by this. So 4 minus 4 is greater than 3 minus 4. Obviously, that means that 0 is greater than minus 1. Also true. So the order or sense of the inequality does not change. It is again x, this side is greater than this side. Simple. Whether you add or subtract any number on either side. Multiplying or dividing each side by a positive constant, remember. So for example, let's just say again we had, let's say 6 is greater than 4. Okay, now let's just divide both of these sides by plus 2. So 6 divided by 2 is greater than 4 divided by 2, which is very true, because that means that 3 is greater than 2. So similarly, if you multiply any positive, this is very important, positive constant on either side, this left hand side will be greater than the right hand side. Simple. But there is a case in which the order or the sense of the inequality changes, and that's when you multiply or divide each of the side by a negative constant. So for example, again you had 6 is greater than 4. If you divide both sides by minus 2, what do you get? You get basically minus 3 is greater than minus 2, and as you can see, that is not at all true. So whenever you divide by or multiply the inequalities by a negative constant, this symbol will invert. So minus 3 is less than minus 2, and that's indeed very true.